so I checked the homework, and it seemed like most of you guys pretty much understood the majority of it. I know that some of us had a little trouble, I think, with how to type in the answers, or maybe we just forgot about when the index is not a 2, how we have to type that a little bit differently when we type in the answers. So
when it has the little, they say the 4 or a 2, is that what you're talking about?
The index, yep.
But we have to put it in there?
You have to put it in there, because if you don't put it in there, then it
took it in without it.
Well, that's because some of them, when they don't have a number there, it's automatically a 2. And so if you don't put anything there, it's automatically a 2. And so if it's anything other than a 2, then you have to make sure you put it in there. It's one of those things like if you just have an X, it's automatically like 1X. The 1 is understood to be there.
That's where I was.
And so I think all the ones that you had me look at, I think all of them were, you had the right stuff, but you were missing that index number. So you got almost all the credit for each of those. I don't know if you went back and looked, but you got almost all the credit for those, except for that one of them you got something mixed up. I'm not sure exactly what it was, but all the rest were good except for that index. Okay, section 8.3, we're going to do 8.3, 8.4, and 8.5 tonight. Next week we've got our test over chapter 8. Once again, I will be here. I will try and be here by 6:30 to make sure that if you guys have questions and you can get here early, that you can come and ask questions over the chapter test. After the test is over, we don't have anything new to cover. This is the end tonight. So after the test is over, you are free to go next week. And again, so I'll be here at 6:30. We'll work if people have questions until 7:30, and then you can take the test. After the test is over, if you don't want to stay, you're free to go. The following week is when we have our semester finals. So once again, I'll be here at 6:30 and try and answer questions if you have them. All the questions on your semester final will come from, or will be, questions from previous tests that you've already taken. Okay, and I'm not going to search for the hardest. I'm not going to search for the easiest. I'm going to kind of get a sampling of all the tests, okay, with the different topics. So if you want to work on studying your old tests and making sure you know how to do those would be a good idea. So next week after the Chapter 8 test, if you guys are wanting to, first of all, if you want your Chapter 8 test back, if you give me a little bit of time, I can probably get it graded and get it back to you. Secondly, if you want to stick around because you have questions on some of your old tests, I will stick around. If people want to, I will stick around until 9:50, which is our end of class time. If nobody stays, I'm not staying. But if you guys want to stay and get questions answered, I will stay so that you know that you're studying the right thing. If there's something you got wrong on the test that maybe I didn't fix it and make corrections on or whatever. So that's kind of how next week will work. After the test, like I say, if you want to leave, you're free to go. If you want to stay and work on studying for the final, you are free to do that as well. I will try to make sure that the computer review does a good job of going back and covering all the stuff that we've covered that will be on the final as well. But I haven't finished making the final yet, so I'm not quite ready to do that.
So you can choose what's on the subject, like on the.
Yeah, I just have to change the questions and add questions and take away questions and stuff like that. So I haven't.
All the tests would be from the test that we already.
All the questions on the final will be from questions that you've already had to attempt on previous tests. Okay. So if you have questions, you can ask me that later, but let's go ahead and start section 8.3. Everybody have their notes good to go? So we're going to continue talking about radicals. Last week we talked about how to simplify radicals with index of 2, which is kind of the normal, and then with other index numbers as well. Tonight we're going to learn how to add them and then how to multiply and divide them. Okay, and unlike fractions, adding these things are actually pretty easy. The multiplying and dividing are the harder ones this time. So when we add polynomials, remember we had like terms. They were called like terms, and that meant the variable parts were exactly the same. And if the variable parts were exactly the same, we could add them together or we could subtract them by combining the numbers in the front. So for instance, looking at this one right here, simplify 5x plus 3x minus 2x, since they're all x's, right? They're all like terms. We would do 5x plus 3x minus 2x, and 5x plus 3x is 8x, and then minus 2x would be 6x. I don't have my markers out. I don't have a lot of things out. What was I doing? Sitting around doing nothing. Let me get myself prepared here. That'll give you time to, get here. So, there we go.
Can you already give us a test?
Yes, but you weren't here.
Can I have it?
No way.
Can I see how bad
In a
is it?
second. So anyway, we get 6x because we add the numbers and subtract the numbers in front of those x's. Okay? So that is the first thing. When we add or subtract radicals, we have to add or subtract radicals that are what we call like radicals. Okay? And like radicals are very similar to like terms. Notice here how the variables had to be exactly the same. When we do radicals, the radicals have to be exactly the same.
Radical is in the inside.
The radical is this stuff right here. So the index numbers all have to be the same. They're all 2 because nothing's written there. And then the inside numbers have to all be the same. They're all 11s in this case. And so we would do the same thing. We would take the 5 plus the 3, which is 8, minus 2, and we would get, instead of 6x, like up here, we would get 6 square root of 11. So the rule is the same, but instead of the variables having to be exactly the same, it's the radical part that has to be exactly the same. Okay, does that make sense? And we're going to do some more examples here, but that's what we're going with. Okay, so are we okay with that first example?
That's at least something.
Was it better or worse than you thought?
Better.
It's better than you thought.
I thought it was gonna be horrible.
Horrible. All right. So, and this is just a reminder. To add like radicals, we first simplify each radical into simplest radical form. So remember last week we had to do some simplifying. So notice all these numbers right here, 5th root of 6, 5th root of 3, 5th root of 3, 5th root of 6. We want to simplify them if we can. Okay? And then if we can simplify them, then we can see which ones might be like radicals and which ones are not. So let's think about this 6. Remember how we were simplifying last week? If we think about the 6, how can we break up the 6? 2 and 3. Is that going to give us any pairs that can escape from the jail?
No.
No. Remember, we have to have pairs in order for them to get out. So, and then 3 is prime, so we can't do anything with that. So we can't simplify any of these individually. But do we have any like radicals that we can combine?
Yes.
So I'm going to start with this one. Are there any like radicals that can combine with that one?
The last one.
The last one, right? Notice how the radical parts are identical. 5th root of 6, 5th root of 6.
Mm-hmm.
So this part right here has to match up exactly with this part right here in order to add them together. Okay? Then we add the numbers in the front. So we have a 7 here. What's automatically in the front of this? A 1. So when we add them together, what do we get? 8. So we will have 8, and then this part just stays the same, 5th root of 6. And then we go to the next one, and notice we can combine with this one, because they're both 5th root of 3. So what are we going to get this time when we have a 4, 5th root of 3, and a -9, 5th root of 3?
-5.
Yes, -5 times the 5th root of 3. And then since these are not exactly the same, we can't combine them. So this is our answer right here. We're done. Does that make sense that these are different right here? And if they're different, you can't combine them. You just leave them alone. Okay. I know she's not going to be here today, so if you wanted to move over to that spot, you could maybe have a better view.
No.
Are you okay? Okay. I just was trying to get you a better line of sight there. Oh, then you might be in his way. All right. So does that make sense?
Okay.
We need to build a special pyramid system here. So.
Is that good?
Yeah.
There you go.
All right. So does that make sense on this one?
Mm-hmm.
So you can only combine them if they are identical with addition and subtraction. They have to be identical. And I'm going to erase this. So if you have a question, ask now. Okay, but sometimes, like I said, we're going to have to do some simplifying first. So let's take a look at this one. As we see this, none of these are the same, right? You got a 45, an 18, a 98, and a 20. So none of them are the same right now, but let's see if we can break them down and make them, once we simplify them, maybe they will be the same. So let's start with the 45. How can we break up this 45?
9 times 5.
9 times 5. 5 is prime, and then how can we break up the 9?
2 and 3.
3 and 3. So that means in here we've got a 3, and a 5, correct?
Mhm.
So what are we going to be able to take out?
3.
A 3. And remember, they have to have a 3, and so this, when we take it out, we'll have 5 times that 3, and then inside the radical we'll still have that 5. So that's the first one. And let's go ahead and simplify this. This becomes 15 square root of 5, because you just multiply the 5 and the 3 together on the outside. Plus, so let's break up the 18. If we're looking at 18, how can we break that up?
6 times 3.
6 times 3. And then the 6 can break up into
3 and 2.
3 and 2. So notice we're going to have a 2 times a 3 times a 3. So what are we going to be able to take out of this one?
3 and 3.
A 3 again, because we've got a pair of 3s. So we'll pull that out. The 6 is already out there. We're going to pull out the 3. And what do we have left inside?
2.
2. So when we combine these by multiplication, 6 times 3 is
18.
18. And then we still have the square root of 2. Okay, well, let's go on to the 98. So if we want to break up the 98, how can we break up 98? That one's a little tougher.
Times 2.
Yep, we know 2 goes in there because it's even. So 2 times 49, and then 49 breaks up into
7.
7 times 7. So this one is 2 times 7 times 7. So what are we going to be able to take out of that one? A 7. So we've got a minus 2 already on the outside. Now we're taking out the 7. And what do we still have left inside? This 2 right here. So this becomes minus 14, 2 times 7, square root of 2. And then the last one is a 20. So how do we break up the 20?
3 times 10.
Okay, 2 times 10,
2 times 5.
and then 2 times 5. So we've got 2 times 2 times 5. What are we going to be able to take out of there?
2.
A 2, because we have a pair of 2s, and that allows us to take out the 2. There's nothing else out there with on the outside, so we're just going to have the 5 left inside. So this is just 2 square root of 5. All right, we've done all of our work now. We've simplified. Do we have any like radicals now?
Yes.
Yes. The first one matches up with
The 2 and the last.
the last one. So what do we get when we add those two together?
7.
15 plus 2 is 17. And then the square root of 5 stays the same. And then notice the 2 middle ones. They match up, right? And so what will we get when we actually subtract or add a negative? What will we get? We'll get a 4. And then the square root of 2 just stays the same there as well. So that is our answer. And again, once this one and this one are not the same, we have to stop. Okay. Does that make sense? Okay. Any questions before I go on? Let's go on then. All right. So what happens if the index is a 3? Well, very similar. And again, we did this last week with the simplifying. We see right away there's nothing that's the same, right? cube root of 54, cube root of 16, cube root of 9. So nothing is the same, but we want to try to simplify and see if anything will end up being the same. So let's start over here with the 54. If we're going to break up 54, how can we start breaking that up? 3 times 18. All right. It's an interesting combination. Not one I would have come up with, but there you go. And then we can break up the 18. What's that?
3 times 6.
Okay. And then the 6 becomes
2 times 3.
2 times 3. Okay. Now, when we do this, we've got 2 times 3 times 3 times 3. How many do we need in our group this time in order for it to escape from jail or whatever you want to call it?
3.
We need 3 because this index is a 3. That tells us we need a group of 3 in order to get that out of the radical. So the 4 is already here. We're taking out a 3 from the radical, and then this is still the cube root of, and what else is left in there?
2.
2. So this is 12 cube root of 2. And then we're going to put our minus sign here. Now I'm going to break up the 16. So 16, how can we break that up?
2 times 8.
Okay, 2 times 8, and 8 breaks up into?
2 times 4.
Yep, and then 4 breaks up into?
2 times
2 times 2. Okay, so this is 2 times 2 times 2 times 2. What can we take out? A 2, but we can only use 3 of them, right? So we have to have a group of 3. So we've got this 9. We're able to take out another 2 because of that group of 3, and we still have what's inside? Another 2. That one leftover 2 that didn't get in with his friends when they escaped. So that means we've got 18 on the outside, and then the cube root of 2. And then we're going to have plus 5. All right. And let's see what we can do with this other one. We've got a 9. How can we break up the 9? 3 times 3. Does that help us?
No.
No, because we need a group of 3, right? So if I have 3 times 3, that's no good. That doesn't help us. So we just have to leave that one alone. If I can't take anything out, I leave it alone. So cube root of 9 stays as it is. Okay. Now, do we see any like radicals? Where?
The first 2.
The first 2 have cube root of 2, right? And so what do we get when we combine those 2?
Minus 6.
Negative 6, and then cube root of 2. That part is
cube root of 2.
cube root of 2.
Square.
I just say it really fast. All right, and then plus, and then this one we can't do anything with, so we just write it down. And so that is our answer for that one. So you won't always be able to combine things, but the goal is to figure out if you can, and if you can, go ahead and do it. Okay, does that make sense? Any questions? Right. That's it. See, first lesson easy, right? If you did well in last week's, because last week was like the introduction to this. So 7 problems there for that one.